KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we start with the transition of electron. Why? Because regarding the transition of electron, in our last class we completed 3 points. So remaining 2 points we will discuss now. Okay, right. So I will repeat once again. Regarding the transition of electron, what are the points we discussed? I will repeat once again for continuation purpose. Okay, right. See here. So transition of electron, by seeing this word, I hope you are able to imagine. So what happens to the electron when it is revolving in one orbit, right? I already told you, when the electron gains energy, when electron gains energy, right, and when this energy is sufficient regarding the two orbits, regarding the energy difference of two orbits, then this electron jump from lower orbit to the higher orbit. Similar to this situation, when the electrons are revolving in one particular orbit, if it lose some energy, then it goes to the lower energy state, right? So here energy will be released. So in one case, just now I told you energy absorption. In the next neighboring case, it is what energy is released. Okay. Anyhow, this energy is equal to the energy difference between those two respective orbits. That is important. And that energy is equal to h nu. That is equal to hc by lambda. That is equal to hc by lambda, right? So here this is what jumping of electron from one orbit to the another orbit is, simply we are calling it as transition of electron. Transition of electron. Okay. So here itself we derived, we had expression for energy difference, that is what energy of emitted radiation. Similarly, we had expression for frequency of emitted radiation, and then the formula for number of spectral lines. Okay, right. If you see that first one, that is what energy of emitted radiation. Energy of emitted radiation, delta E is equal to E2 minus E1 is equal to minus RCH Z square by N2 square minus of minus RCH Z square by N1 square. That is equal to 13.6 Z square into 1 by N1 square minus 1 by N2 square, right? This is what energy of emitted radiation. So what is the energy of emitted radiation, ma? So delta E is equal to 13.6 Z square into 1 by N1 square minus 1 by N2 square. Next, frequency of emitted radiation. Frequency of emitted radiation, delta E is equal to h nu. Nu is equal to delta E by h. Okay, I will give the conclusion regarding the frequency of emitted radiation. Nu is equal to RCZ square into 1 by N1 square minus 1 by N2 square. Okay. Next, third point, that is what number of spectral lines. Regarding the number of spectral lines, okay, the formula is Ne is equal to N2 minus N1 plus 1 into N2 minus N1 divided by 2. Okay, right. If electron falls if electron falls from nth orbit to ground state, if electron falls from nth orbit to ground state, that is n2 is equal to n and n1 is equal to 1. n2 is equal to n and n1 is equal to 1. Then the number of, right, then the number of electrons, the number of spectral lines, then the number of spectral lines emitted, Ne is equal to n into n minus 1 by 2, n into n minus 1 by 2. So till now, these 3 points we discussed in the last class regarding the transition of electron, okay, right. Now see the fourth point. See here I have written fourth point. Fourth point is regarding to wave number or wavelength, wave number / wavelength, okay, right. So it is what wave number, that is equal to 1 by lambda, that is equal to V is equal to n lambda, no, V is equal to C lambda. So lambda is equal to, right, so V is equal to C is equal to, right, V is equal to n lambda or C is equal to nu into lambda, okay. That is what here he has written clearly. And this is what nu by C, nu by, it is nu, it is what like frequency, nu by C is equal to, right, R z square into 1 by n1 square minus 1 by n2 square, 1 by n, it is n1 square, it is n2 square, that is equal to 13.6 z square divided by hc into 1 by n1 square minus 1 by n2 square. So this term can be replaced, with this, that is what 13.6 z square divided by hc, okay, right. So what I am saying is, it is what wave number and it is what wavelength, and this is what like nu, it is like frequency, okay. I think you know how to write nu, which is what frequency, okay. So afterwards, that is speed, okay, it is what c, speed of light, that is equal to r z square into 1 by n1 square minus 1 by n2 square, okay. So 1 by n1 square minus 1 by n2 square, that is equal to 13.6, see here. So 13.6 z square divided by hc, h is the Planck's constant, c is the speed of light, and 1 by n1 square minus 1 by n2 square. So please keep in mind the terminology also, which helps us while solving the numericals. So it is wave number and wavelength and frequency and speed of light, right, Rydberg constant, like that, okay. It is what n1 square and n2 square, z value, that is equal to 13.6 z square by hc, n1 square, n2 square, and it is what Planck's constant, and c is the speed of light, okay. So in fourth point we came to know what is the expression for wave number, and expression for wavelength already we discussed, okay. That is what we discussed, means we can write based on the first point, that is what energy of emitted radiation, otherwise based on the same thing you can write the expression for wavelength, that is what, it is 1 by lambda, no. So lambda, what will happen? So mathematically the terms will become reverse, okay. That is the only difference between wavelength and wave number. Next, fifth point, see here. Due to the transition of electron, photon is emitted and the atom is recoiled. Due to the transition of electron, photon is emitted and the atom is recoiled, okay. See here what he is writing next. Recoil momentum of atom is equal to momentum of photon. Recoil momentum of atom is equal to momentum of photon. So based on that, what can we say? So this is what h by lambda, and that is equal to h or z square into 1 by n1 square minus 1 by n2 square. This is what due to the transition of electron, a photon is emitted and the atom is recoiled, okay, right. recoil momentum of atom is equal to momentum of photon. So this is what the expression ma. Then recoil energy of atom is equal to p square by 2m, that is equal to h square by 2m lambda square, h square by 2m lambda square. This is the expression for recoil energy of atom. Okay, right. Now you see here they have given some of the values for values means, see here they have given one table here. See, observe the table, which is what the energy level. Here we are going to talk about energy level. See this, first principal quantum number, and then orbit, then excited state, afterwards energy for hydrogen atom, okay. So one is principal quantum number, next orbit, next excited state, afterwards energy for hydrogen atom, okay, right. See here, first suppose if you take n is equal to infinity as principal quantum number, then what about the orbit? Infinity, right, infinite, and excited state also infinite, and energy for hydrogen atom is 0 electron volt, Next, when n is equal to 4, the orbit is fourth orbit and the excited state is third, okay, and here the energy for hydrogen atom is minus 0.85 electron volt, Next, when n is equal to 3, orbit is third and it is what? Second, excited state is second, and here the energy for hydrogen atom is minus 1.51 electron volt. Next, n is equal to 2. When the principal quantum number n is equal to 2, here the orbit is second, here the excited state is first, okay, and energy for hydrogen atom is minus 3.4 electron volt, and here the principal quantum number n is equal to 1 and the orbit is first and the excited state will be ground, and the energy for hydrogen atom is minus 13.6 electron volt, okay. So the last one we come across many times, right? Here also you can see, right? So we come across many times the last one, where the principal quantum number is n is equal to 1 and the orbit is first and the excited state is ground state, and the energy for hydrogen atom is minus 13.6 electron volt, okay, right. See here the next thing, that is what we are going to discuss about quantum numbers. Okay. First, there are different quantum numbers. First, we are going to discuss principal quantum number. See here. So, regarding the principal quantum number, in the bracket n, small n, okay. Regarding the principal quantum number small n, see here, this quantum number determines the main energy level or shell, okay. This quantum number, right, principal quantum number determines the main energy level or shell in which the electron is present, okay, right. Here we can write it as En, that is what main energy level. En is directly proportional to 1 by n square. N is the principal quantum number, and you can also write Rn is directly proportional to n square. In hydrogen atom, right? I'll repeat once again. See here, this principal quantum number determines the main energy level or shell in which the electron is present. So En is, you can write based on the theory, you can write any En is directly proportional to 1 by n square and Rn is directly proportional to n square in hydrogen atom. I hope you remember the drawbacks and the positive points, the positives and negatives from Bohr's model, right? So that's you keep in mind always. Next, the principal quantum number takes whole number values. The principal quantum number takes whole number values, that is n is equal to 1, 2, 3, 4 dash 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 up to infinity. Next one, orbital quantum number. The second one is orbital quantum number or azimuthal quantum number. Azimuthal quantum number. It indicates by using the letter small l. Okay, see here. This represents the number of subshells present in the main shell. This represents the number of subshells present in the main shell. Full stop. These subsidiary orbits within a shell will be denoted as 1, 2, 3, 4 dash dash dash. Otherwise, SPDF, right? In chemistry also you are getting SPDF, right? This tells the shape of the subshell. This tells the shape of the subshells. Okay, right. Next point, the orbital angular momentum of the electron is given by L is equal to square root of L into L plus 1 into h by 2 pi. Square root of L into L plus 1 into h by 2 pi. This is for what? For a particular value of n. For a particular value of small n. Okay, right. Next, for a given value of small n, the possible values of small l. For a given value of small n, the possible values of small l are L is equal to 0, 1, 2 dash 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 up to n minus 1. Okay, right. So once you go back to the orbital quantum number and azimuthal quantum number, right? So the name is two different names. So because it is what azimuthal quantum number, and the same thing can also call it as orbital quantum number because it is talking about orbital angular momentum of the electron. Okay, right. So regarding this quantum number, this quantum number represents the number of subshells present in the main shell. That is the main point to keep in mind. Then these subsidiary orbits within a shell will be denoted as 1, 2, 3, 4, 1, 2, 3, 4 or SPDF, S, P, D, F, and this tells. So this is what the situation tells the shape of the subshells. Okay, right. And next more important point in this orbital quantum number is while calculating the orbital angular momentum. The orbital angular momentum of the electron is given by capital L is equal to square root of small l into small l plus 1 into h by 2 pi. This is like a formula to calculate orbital angular momentum in terms of azimuthal quantum number. That is what capital L is equal to square root of small l into small l plus 1 into h by 2 pi. This is for a particular value of small n. Okay. Next, for a given value of small n, the possible values of small l are small l is equal to 0, 1, 2 dash 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 up to n minus 1. Next thing. Next, third one, magnetic quantum number. That is what small m suffix small l. This is the notation to represent magnetic quantum number. See here. So regarding the magnetic quantum number, observe carefully. An electron, due to its orbital motion around the nucleus, generates an electric field. So it is that what you have to go back to our discussion, that is magnetic effects of electric current. Okay. Sorry for that. See here. here he is not talking about magnetic field. See, he is talking about electric field only, right? So, as simple as such, when the electron is in motion, it's like a source of electric field. Okay, even when the electron is at rest also, it is like what is a static electric field. Okay, so that's why here the point is, when the electron is in motion, see here, an electron due to its orbital motion means what? The electron is in motion. When the electron is in orbital motion, the nucleus generates an electric field. Okay, right, full stop. One more important point, he is saying that nucleus generates electric field. So, nucleus means basically that is what protons, protons are neutrons, protons positive charge, right, and electrons negative charge, and opposite charges will attract each other. So, electron is positive charge and electron is negative charge, electron is negative charge and proton is positive charge, right. So, these two will attract. So, resultantly there he is talking about generation of electric field. This electric field is expected to produce a magnetic field under the influence of an external magnetic field. The electrons of a subshell can orient themselves in certain preferred regions of space around the nucleus called orbitals. Okay, right. And just now I told you before 2 minutes, that is what magnetic effects of electric current. That point he is utilizing here. See this. This electric field is expected to produce a magnetic field. So, I told you in the chapter, time varying electric field acts like a source of magnetic field. Okay. So, that only he is talking here. This electric field is expected to produce a magnetic field. Okay, right. Under the influence of external magnetic field, the electrons of a subshell can orient themselves, right? The electrons of a subshell can orient themselves in certain preferred regions of space, around the nucleus called orbitals. Okay, right. So, in these 4 lines of information, he is talking about the presence of electric field, he is talking about the production of magnetic field, right, and he is also talking about how the orbitals are going to form and what are the orbitals. Okay, right. Next point, the magnetic quantum number determines the number of preferred orientations. The magnetic quantum number determines the number of preferred orientations of the electron present in a subshell. Okay. So, I will repeat once again the next point, because it is the intention of the magnetic quantum number. So, that is what the magnetic quantum number determines the number of preferred orientations of the electron present in a subshell. Okay, right. Next one, the angular momentum quantum number, of this quantum number small m can assume all integral values. The angular momentum quantum number small m can assume all integral values between minus L to plus L including 0. Thus, what can we write in place of ml? ml can be minus 1, right, minus 1, 0, plus 1 for L is equal to 1. Total values of ml associated with a particular value, total values of ml associated with a particular value of L is given by 2L plus 1. Okay. This is about magnetic quantum number. So, in magnetic quantum number, he is talking about what is how the electric field is present and how the magnetic field is present there itself, and then what is how the orbitals are going to form and how the orbitals are going to form. Afterwards, he has given the purpose of magnetic quantum number, that is what which determines the number of preferred orientations of the electron present in a subshell, okay, full stop. And then the angular momentum quantum number m can assume all integral values between minus L to plus L, including 0, right? So that because of that you can write ml as -1, 0, +1 for L is equal to 1. So total values of ml associated with particular value of small l is given by 2 small l plus 1, okay, right. In this class here we discussed about some of the points from transition of electron. So those are 4th point and 5th point. Then after we discussed about energy levels regarding the principal quantum number, right? From n is equal to infinity, here n is equal to 4, n is equal to 3, n is equal to 2 and n is equal to 1. What about the orbits and excited states? Then what is the energy of hydrogen atom regarding that particular principal quantum number, right? So that's we discussed, and then we came to discuss quantum numbers. Right? So in this class we discussed what is principal quantum number, right? What is the principal quantum number, and then what is the orbital quantum number, and then what is the magnetic quantum number, okay? So while discussing about the quantum numbers, we had some relations. So that relations also we have to keep in mind, which helps us while solving the numericals related to this topic. Okay, ma? Right. Thank you. In next class, we will continue with next continuation topic. Thank you.